go. So today we are going to discuss about the turning point and the line of symmetry of any quadratic equation. You're already familiar that quadratic equations looks like this one, 2x squared plus 3x minus 2. Let's say we have this quadratic equation. We're already familiar that whenever this type of equation is plotted, it will form a parabola that might look like this one. Okay. So a new thing has been introduced, and you will see a few questions in your past paper where you will be asked to find out the turning point of quadratic equation. There are multiple ways of finding out the turning point, but there is also an easy method to find out it. If you look at the equation, you are familiar that A is equals to 2, B is equals to 3, and C is equals to minus 2. If we have to find out the turning point, we'll use a simple formula. That formula is x is equals to minus b over 2a. So, you are already familiar that x is equals to minus b over 2a. What does it mean? You are going to substitute values here, that's negative, and in place of b, we'll substitute the value, that's 3, over 2 into a, where the value is 2. So it's going to be minus 3 over 4. This minus 3 over 4 represents the x coordinate of the turning point. That might be somewhere over here or somewhere here or wherever. That's the closest possible place. That's negative 3 by 4. We know that a coordinate is always stated in the form of x comma y. Now you have calculated the value of the x coordinate. Okay. If we substitute this value in the equation, we'll be able to find out the corresponding y value. So your equation is y is equals to 2x squared plus 3x minus 2. We'll substitute the value of x in this equation like this. That's 2 bracket start, that's negative 3 over 4 raised to the power 2 plus 3 bracket minus 3 over 4 minus 2. You will substitute this value in calculator. It will produce a value of negative 3.125. So this represents the corresponding y value. So that is minus 3 by 4 comma minus 3 whole minus 3.125. So this is the coordinate of the turning point. Let's take another example. Let's say we have an equation y is equals to 3x raised to the power 2 minus 4x plus 2. And we have to find out the turning point of this. We're going to use the formula, that is x is equals to minus b over 2a. We're going to substitute values. That's negative b is equals to negative 4 over 2 into a is 3. So that's going to be equals to 4 over 6. That can be simplified into 2 by 3. Right? Now what we are going to do, we are going to substitute this in the formula. That's the original quadratic equation. We just need to substitute the value of x. We'll get our answer. So I'm using calculator for this purpose. So it is producing a value of 2 by 3, which means that the corresponding y coordinate is going to be 2 by 3. So you can say that the turning point is turning point of the equation is 2 over 3 comma 2 over 3. So this represents the turning point of the equation. Now, just one more thing associated to it. For example, if we look at the equation, we can see that this minimum point, okay, this minimum point is also the turning point. When this is the turning point, we can use its corresponding value of x as the equation of line of symmetry. So in the first equation, our line of symmetry will be equals to x is equals to minus 3 by 4. And in our other case, in the second question that we have solved, you can see that this is your x coordinate and this is your y coordinate. So the equation of line of symmetry is x is equals to 2 by 3. This is the simplest possible mechanism of finding out the line of symmetry and the turning point. You just have to simply use the formula for finding out the value of x. Once you have the value of x, just replace it in the equation. You will get the corresponding y value, and this will represent